ratio and proportion, similar figures, scale drawings, it's all something we've already touched on, but of course we're going to dial it up a little bit today. So we're just going to start off with simplifying some simple fractions, because being able to do that will make the ratio and proportion portion a lot quicker, a lot easier. So 49 and 84, those are both divisible by 7. 7 goes into 49 7 times. Woo! We'll see when that shows up. And 7 goes into 84 12 times. Maybe that'll show up. Okay, there we go. 7/12. Come on, there we go. All right. 24 and 42. Hey, you can always start with even numbers, all divisible by 2, and then you could keep doing that. So half of 24 would be 12, half of 42 would be 21, and you're like, oh, well, I know 3 goes into those. 3 goes into 12 4 times. That's the weirdest 4. I think I started writing a 3. And then 3 goes into 21 7 times. So just knowing a couple divisibility rules, you can figure out simplifying. You could do it in 5 steps, or you can do it in 1 if you can find the largest one. I see these both end in a 5, so I know that 5 goes into them. 5 goes into 135, that's 140, it's 28, so that would be 27. And then 5 goes into 180 36 times. Then you're like, oh, wow, 9 goes into both of those. 9 goes into 27 3 times, 9 goes into 36 4 times. Now, when you are multiplying fractions, this trick is so helpful to know. You can simplify vertically or diagonally. So like 35 25ths, 40 14ths. You can simplify any set of those as long as you have one from the numerator and one from a denominator. So like 25 and 40, 5 goes into both of those. 5 goes into 25 5 times, 5 goes into 40 8 times. And then with 14 and 35, those are both divisible by 7. 7 goes into 14 2 times, 7 goes into 35 5 times. And then you look and you're like, oh, 5 and 5, you just cancel those out. So we're left with 8 over 2, and 8 divided by 2 is just 4. Look at that. Crazy. 99, 144, 96, 88, 88 and 99. 11 goes into both of those. Goes into 99 9 times. Goes into 88 8 times. 96 and 144 are both divisible by 12. 12 goes into 96 8 times. 12 goes into 144 12 times. Hey, I see an 8 over 8. 8 divided by 8 is just 1, so those cancel each other out. So we're left with 9/12, which would simplify to 3/4. All right, last one. 21 81, 108 56. Well, 21 and 56 have 7 in common. 7 goes into 21 3 times. 7 goes into 56 8 times. 81 and 108, I know are both divisible by 3. So 3 goes into 81 27 times. 3 goes into 108 36 times. Let's see what else we can do. Okay, 27 and 36 are both divisible by 9. 9 goes into 27 3 times. 9 goes into 36 4 times. I see a 3 over 3. And we're left with just 4 over 8, which is 1/2. Just got a little tough there at the end. So proportions, easiest way to solve proportions, which is a fraction equals a fraction, a ratio equals a ratio, is to just cross multiply. So multiply diagonally. So if we're solving t over 9 equals 5 over 6, I'm going to multiply diagonally. T times 6, oh goodness. T times 6 would be 6t, and you set that equal to the other cross products. 9 times 5 is 45. Now that's a pretty basic equation, what you have left. So just divide by 6 and simplify. Now we're dealing with fractions, so I don't want the decimal version of this. I want the fraction version of this. Those are both divisible by 3. 3 goes into 45 15 times. 3 goes into 6 2 times. So 15 halves. So keep it going. I'd like you to try these 3 out, cross multiply, and then solve what's left, and then check back in. We could simplify first here. Cut these in half. 9 25ths. There we go, 25m. We move over. Times 15 is 135. So 5 goes in 135. 27 times. And 5 goes into 25 5 times. Cool. All right. You ready to dial it up? Me too. Multi-step proportions. Same thing, you multiply on the cross products. But if we're doing this one, we're doing 7 times the x plus 4. So here's how we're going to write it. We're going to write it like a distribution problem, because we have to do 7 times each of those numbers equals 5 times x minus 2. Whoa, fun. All right, we'll distribute 7x plus 28 equals 5x minus 10. I feel a sneeze coming on. Scoot that down. So we got to get the x's on the same side. I would subtract 5x from both sides. 2x plus 28 equals negative 10. Oh, let's subtract that 28. What do you say? 2x equals negative 38. And then move that down. Oh, goodness. Oh, me, oh, my. There we go. And then we'll divide by 2. Maybe. There we go. And we get x equals negative 19. I think I wanted to move this down, not the video. I don't know. What is going on here? What is going on? So let's say try 2 of these 3. Check back in. I'll do all 3 of them, and then you can check your answers. You know what? You could do 7 and 35. Otherwise, we can simplify it to 7 goes into 35 5 times. So now we have 5 times y plus 4 equals 1 times y minus 15. And 1 times y minus 15 is just y minus 15. So I'm going to subtract a y. So they get pretty tough. Now we're going to go into some word problems. Some similar figures. Now the thing about similar figures are the corresponding sides are in proportion to one another. So these work great for word problems because they're actually pretty easy to set up correctly because there are 4 different ways you can set it up correctly. There's also 4 ways you can set it up incorrectly. So you got a 50-50 shot of setting it up perfectly. But what I always say is like consistency is key. So let me show you what I mean here on this first one. In the figure at the right, triangle ABC is similar to triangle DEF. Find DE. So line DE is this one, if that shows up. I'm going to call this side X. So line DE on the other triangle corresponds with line AB. And line EF, or FE, corresponds with line CB. So, if you want, one way you can set them up is, here's the way I would set this up. I would say x over 24 for my first fraction. Now look where I got those numbers. I did the top right side over the bottom side. So if that's the case, on the other fraction, I have to keep that same order. Top right side over the bottom side, which would make it 27 over 32. That's one way you can set it up. Let me show you another way. Let's say I was like, okay, well, x matches up with 27. So I did small triangle over the corresponding big triangle. So the other fraction, I would have to do small triangle over big triangle, which would give you 24 over 32. But if you look at either way we set it up, our cross products are x and 32 and 27 and 24. Now, if you'd like, you can always simplify a fraction before you multiply. If you have a calculator and you're just tossing the numbers in there, it doesn't really make a huge difference. But like 24 and 32 are both divisible by 8. So 8 goes into 24 3 times, 8 goes into 32 4 times. So now we're doing 4 times x, 4x, equals 3 times 27, which is 81. And then if you divide that by 4, you can't simplify 81 fourths. If you did the decimal version of it, it comes out to 20.25. Which, let's think of the multiple choice options there. Is that one of them 20.25? Yeah. So that's option C. Now also, it's important to make sure your answer makes sense. 20.25. So the top right side on this one is 27, the bottom side is 32. So the top right is pretty close, but it's a little bit smaller. So make sure your answer is pretty close to the bottom, but a little bit smaller, which it is. If you ended up with like 33 there, you're like, oh, it doesn't make sense. So it's wrong. So I should check over my work a little bit. Maybe I made a simple mistake. These work great for word problems. A tree casts a shadow 7.5 feet long. A woman 5 feet tall casts a shadow 3 feet long. The triangle shown for the tree and its shadow is similar to the triangle for the woman and her shadow. How tall is the tree? So I'm going to move up here. We're going to set up a proportion. Again, you can set it up many ways, and it's still going to be good. But they said the woman was 5 feet tall. Oh boy. Oh boy. I should have read that first. 5 feet. Okay. So if we were to set up a proportion, let's say I said the height of the lady, 5, over her shadow, 3. So I did actual height over shadow. The other fraction, I'd have to do actual height over shadow. They told us the shadow is 7.5 feet. We don't know the actual height. Let's call it h. And then we can cross multiply and solve. 3 times h, time it out. What up? It's all right. Yeah, you're welcome. Sometimes the crowd just demands your attention. All right, 3 times h is 3h. 5 times 7.5, 5 times 7.5, 37.5. And then we just have to divide it by 3. 37.5 divided by 3 is 12.5. And this was in feet. Let's make sure that answer makes sense. This was 12.5. The actual height is almost double the shadow. 3 times 2 would be 6. So it's almost double that. 7.5 times 2 would be 15. And this is just a little bit under 15. Great. Let's talk more shadow problems. They love the shadow problems when you're doing similar figures. They love it. And I love drawing on the video portion of the screen. It sounded like I was doing an accent. The video portion. Now, I prefer to draw these out when I'm doing it. It makes it easier for me. A tree casts a 26-foot shadow. Here's my tree. Here's my 26-foot shadow. A boy standing nearby casts a 12-foot shadow. Here's the boy, 12-foot shadow. His height is 4.5 feet. How tall is the tree? It's called the tree X. Set up a proportion. Let's say I did the height of the tree over the shadow, X over 26, and then the height of the boy over his shadow, 4.5 over 12. If you cross multiply, we'd have 12x equals 26 times 4.5 is 117. And then we'll divide it by that 12. X equals 9.7. Let's make sure that makes sense. 9.75. All right, so 9.75 is basically 10, and 10 times 2 is 20, and then it's a little bit more. 4.5 is pretty close to 5. 5 times 2 is 10, and then it's a little bit more. Perfect. That sounds great. So check your answers for reasonableness. And that is a quick way to check if you definitely made a mistake and need to go check your work over again, or if you feel pretty comfortable with your answer. A house casts a shadow, a 56-foot shadow. Here's my house. Here's my 56-foot shadow. A girl standing nearby casts a 7.25-foot shadow. 7.2. Her height is 5.4 feet. What is the height of the house? Wow, this is not drawn to scale. That's okay. That's okay. So let's say the house over its shadow, x over 56, equals the girl over her shadow, 5.4 over 7.2. Now look, the shadow is just a little bit longer than the height of the girl. Right? It's like 1.5 times. So x times 1.5 should be about 56. So if I was guessing, maybe around 38, 40-ish would be a guess. So if we were to cross multiply, we'd have 7.2x equals 56 times 5.4 is 302.4. And we will divide that by 7.2. 42. Yeah, I was pretty close. 42 feet. Nice. All right, the other kind of problems with these similar figures, proportions, are scale drawings. And usually they use scale of a map. So the scale of the map at the left is 1 inch to 10 miles. The nice thing about this is that could be our first fraction. 1 inch to 10 miles. But like I've said all along, consistency is the key. So if we're doing inches over miles here, and on the other side, we're going to also want to do inches over miles. Approximately how far is it from Valcaria to Wabasso? So here's Valcaria. Here's old Wabasso. So that looks like it's 1, and let's see, here's full inch, there's a half inch, so quarter inches. So 1 3/4 of an inch, which if that was in decimal form, that would be 1.75 inches. We don't know how many miles it is, so let's call it x. Now, when we cross multiply, we don't need the units here. We're just doing 1 times x is 1x equals 10 times 1.75 would just be 17.5. And that's it. There's nothing else to solve there. X equals 17.5, and that was miles. You know that wasn't even bad. That wasn't even bad.